Hi, sixth graders. Today we're taking a look at lesson 23, but before we do, I'd like you to turn to yesterday's homework, which was on 247, and we're going to take a look at your answers. You had to answer any three of the seven, so I'm just going to read off all of them and you can check your paper. So again, page 247. And number 1 is 2,250. Number 2, 2,250 miles. That's the important part. Number 2 is 40 centimeters per second. Number 3 is 50 centimeters per second. Number 4 was 3,450 miles. Number 5 is 275 miles. Number 6 is 13.1 miles per hour. And number 7 was 5,100 centimeters. So after you've taken a look at the problems that you did, if you have questions, don't understand what you did wrong, make sure you come and see me so that I can show you and we can find that error. All right, looking at lesson 23, problem solving using rates, unit rates, and conversions. So the goal for today is that you'll be able to solve constant rate work problems by calculating and comparing unit rates. Now, in the last lesson, we learned about constant speed problems. We did distance is rate times time. Today, we're going to learn about a constant rate work problems. So what do you think constant rate, what does that mean if it's a constant rate work problem? Yeah, hopefully you remember when we've talked about constant before, it means that something doesn't change. It stays there and it doesn't change. So we're going to say that this person, because it's a rate and it's about work, this person is going to be working at a constant speed. Looking on the first problem, it is on page 249, and it says, suppose that on a Saturday morning you can cut 3 lawns in 5 hours, and your friend can cut 5 lawns in 8 hours. Your friend claims he is faster working than you. Who is cutting lawns at a faster rate, and how do you know? So not only do we have to answer the question, find out who it is, but we have to tell how do we know. So looking at the first one, let's look back to what we've done previously. If we can do 3 lawns in 5 hours. So I'm going to go ahead and write it. 3 lawns. Now on yours, you have lines there. So actually, I don't even know if they have, yeah, they do have lawns. 3 lawns and 5 hours. And then we need to get that to a unit rate. And hopefully you guys can remember what a unit means. What does it mean? Yeah, our bottom number has to be a 1. So we need this to be a 1 hour. So how did we get from 5 to 1? We divided by 5. And since we did that to the denominator, we're going to go ahead and divide the numerator by 5 also, which would be 3/5. Now, if we wanted to reduce that, we could actually say 3 divided by 5, which would make it maybe easier to read in this instance. So we would get 0.6 lawns per hour. Now, 0.6, what does 0.6 mean? Well, it's the first decimal or place after the decimal, so that's the tenth spot. So it's 6/10. So it's a little over half of a lawn because half of a lawn would be 5/10. So in 1 hour, they're doing just over half of a yard. Now let's go back and do our friend. Our friend thinks they're going to do 5 lawns in 8 hours. So 5 lawns. So glad you guys don't have to write this whole time, right? 5 lawns, 8 hours. Okay. And again, let's get it to unit rate. So we need a 1 on the bottom. And how do I get from 8 to 1? We divided by 8. So let's go ahead and do that same thing on the numerator. And 5 divided by 8 is 0.625, I believe. Hopefully I'm right on that. Yep, 0.625. So when we write our label on this, they're doing 0.625 yards, or lawns, I guess it would be, yards per hour. All right, so as we take a look at this, we now need to compare who does it faster. Well, since they're both per hour, we need to look at which one did more per hour. And in this case, 0.6 would be the same on both of them if we were going to compare them. The 10th spot is the same, and the 100th spot here is a 0, and over here would be a 2, so that's greater. So your friend would actually be the faster. So who should win? The friend. My friend is faster. How did you find out? Because I compared the 2 units, and he is barely faster. Okay, and how should it be written? If you were really going to write this out, make sure it would be looking like this. And then we need to know how to read it. So if I can cut 3 lawns in 5 hours, that equals 3/5 of a lawn in an hour. If a calculator is used, that will be a unit rate of 6/10 of a lawn in an hour. Next problem. All right, so when we look at, as we take a look at our friends, we've already done that. We put that on the first page, so we got 0.625. And how is that interpreted? Well, if my friend cuts 5 lawns in 8 hours, the unit rate would be 0.625 lawns per hour. Now, if we're going to compare the fractions, okay, in order to compare fractions, we're going to have common denominators. So one of the ways that we could just compare those two fractions is by finding our common denominator between a 5 and an 8. What do 5 and 8 both go into? So you're counting by 5s, 5, 10, 15, 20, and you're doing that until you find a number that 8 goes into also. Hopefully you've noticed that if we pick the number 40, 5 times 8 is 40, so we know both of them goes into 40. Now, how did I get from 5 to 40? What did I have to multiply by? 8. So 3 times 8 is 24. So 3/5 is equivalent to 24/40. Now let's take a look at the second fraction. How did I get from 8 to 40? I did times 5, right? So 5 times 5 is 25. So 25 over 40 is equivalent to 5/8. So all we've done is we've written them as equivalents with the same denominator. So if we're now talking about a pie and it has 40 pieces in it, which would you get more of? If you have the pie with 24 pieces left or the pie with 25 pieces left? Well, 25 pieces is bigger, so 25/40 is larger, which is your friend's rate. That's not what I wanted. There we go. So my friend is a little faster, but only 1/40 of the lawn per hour, so it's a very close race. All right, the next one. It says, next, suppose you own a restaurant. You want to do some advertising, so you hire 2 middle school students to deliver takeout menus around town. One of them, Darla, delivers 350 menus in 2 hours, and another employee, Drew, delivers 510 menus in 3 hours. You promise a $10 bonus to the fastest worker since time is money in the restaurant business. So who gets the bonus? All right, so let's take a look. When we write our fractions out completely, we are going to first take a look at our friend Darla, and Darla can do 350 menus in 2 hours. So we need to go ahead and write 350 as our menus, and we know that is in 2 hours. So 2 goes in the bottom in our denominator. And then we're going to go over here and find Drew, and Drew can do 510 menus in 3 hours. 510 in 3 hours. All righty. And now we're going to find out how much they can do in 1 hour. Let's find that unit rate. Well, how do I get from 2 to 1? Yeah, right. We're going to divide by 2, right? Divide by 2. We're going to cut that in half. So 2 divided by 2 is 1. And then 350 divided by 2. If you're not sure, what should you be doing right now? You got it. You should be actually dividing that on your calculator or on the paper off to the side. Either way, dry erase board, something. Go ahead, work it out. If we do it down below here, we're going to get 350, just like that, divided by 2. 2 goes into 3. We subtract, and we get a 1. Bring down our 5. 2 goes into 15 7 times, which is actually 14. 15 minus 14 is 1. And bring down that last number, which is a 0. 2 goes into 10 5 times, and we end with 175. So Darla can do 175 menus in 1 hour. Okay, I'm going to go ahead and get rid of this just so I can write there. All right, let's go ahead and let's do Drew's. Drew can do 510. How do we get from 3 to 1? Yeah, good job, guys. We're going to divide by 3, and we're going to divide this one by 3. I was getting ahead of myself over here dividing already. So 510 divided by 3, and 3 goes into 5 once. 5 take away 3. Yep, leaves us 2. Good job. Bring down my 1. 3 goes into 21 exactly 7 times. And therefore, if we just have a 0 left, what do we need to do with that 0? Yeah, we would really bring it down, but nothing, or 3 is not going to be able to go into 0, so we're just going to add that 0 up top. So he can do 107 menus. Oh, wow, look at that. Who's going to get the bonus? Yeah, Darla. Darla's going to get it. She must be really quick, right? Darla gets the $10. Yay, Darla. Perfect. Good job. All right. We need to take a look, though. What happens if you wrote them backwards? Now, looking at this, a common mistake, it says 350 menus in 2 hours. And then we actually reduced it to the unit rate, and we wrote 175 menus in 1 hour. Well, look at Drew's. Notice Drew's, I accidentally put the 3 hours on top. So I said, in 3 hours, he can do 510 menus. That is so true. But in this case, notice that my unit is now on top in that second part of the ratio. So I have 1 hour. So in 1 hour, he can do 170 menus. That's correct. However, it's not a unit rate because unit has to be on the bottom. So what happens if they do not match and one is inverted or flipped? It just makes it hard to compare them. Okay, it's just not a good way. We would have to say 175 menus would be delivered per hour by Darla, and it would take an hour for Drew to deliver 170 menus. Mixing them up just makes it awkward. All right, last one. Survival of the fittest. Which runs faster? A cheetah that can run 60 feet in 4 seconds, or a gazelle that can run 100 feet in 8 seconds? So let's go ahead. We're going to take a look at our cheetah here. And our cheetah can do 60 feet in 4 seconds. So fill in 60 feet in 4 seconds. How do I get from 4 to 1? I divide by 4. And how do I get then from 60? I have to divide it by 4. And that would be 15. So that cheetah can run 15 feet in 1 second. Well, let's take a look at this gazelle. A gazelle can do 100 feet, but it takes him 8 seconds. Well, how do I get from 8 to 1? Divided by 8. So 100 divided by 8. Now, I know that that's not a perfect answer, so I'm going to go over here and divide, okay? 100 divided by 8. 8 can go into 1. No, it can't, right? It can go into 10, though, one time. Make sure we put that 1 above the 0, not above the 1. 10 take away 8 is 2. Bring down my 0, and 8 goes into 20. 2 times, which is 16. Now, right away, I can tell by looking which one is going to be faster. But I'm going to go ahead and continue. Since 8 can't go into this 4, I'm going to add a decimal here. And remember that where I add a decimal, I can then add a 0 to bring down. Because looking ahead, I could kind of see that if I added a 0, 8 could have went into this 40 exactly 5 times. So I was looking ahead at that. So when I subtract, now it comes out beautifully. So it is 12.5 feet. So a gazelle can only go 12.5. The cheetah can go 15. So the cheetah is quicker than the gazelle. Now you don't have to write anything down here, but we're going to take a look at this. It says, what if the units of time are not the same in the 2 rates? The secretary in the main office can type 225 words in 3 minutes, while the computer teacher can type 105 words in 90 seconds. Who types at a faster rate? Well, what they're trying to let you see is that in this one, we have the first that's in minutes and the second that is talking about seconds. We can't compare that evenly or easily. So do we have to change them? Yes. Okay. What happens if we don't convert them? It's going to be so difficult to compare. So we really need to make sure we change them. Does it matter which one we change? No. We can change either of those. But we do need to know what's the connection between 3 minutes. Okay? So if I wanted to change my 3 minutes into seconds, oh, look, this is what we did the other day, right? What's the connection between minutes and seconds? I need my minutes on the bottom here so it'll cancel. What is the connection? Oh, I'm so glad. 1 minute is 60 seconds, right? So now we can multiply or cross cancel. Can I cross cancel anything? Yep. I'm glad you saw that. Minutes and minutes. Nothing else can be canceled. So 60 times 3 is 180. 180, and all my label is left is seconds. So if I change them to seconds, I would cross off this 3 minutes, and instead I would write 180 seconds. Now, if I wanted to do the other one and change 90 seconds, I would go right over here and I'd say 90 seconds. And I'm going to change it to minutes. And again, our connection is 1 minute is 60 seconds. And in this case, what can I cross? Awesome. Cross off those seconds. Now, I can also cross cancel 90 and 60. What goes into both of those? For sure, a 10, right? So 10 goes into 90 9 times, and 10 goes into 66 times. Ooh, I also see 9 and 6. 3s are going into there, right? So 3 goes into 9 3 times, and 3 goes into 6 2 times. Can anything go into 3 and 2? Nope. So multiply straight across, and we get 3 minutes is on the top, and all I had left was a 2 on the bottom. So really it's going to look like this. It'll be 3/2 minutes, which, holy moly, does that make sense? No. Big kid sitting on a little kid. Don't want it, right? So 2 goes into 3 one time with 1 left over. Bottom number, denominator never changes. So it's 1.5 minutes. Could also be written as 1.5. Okay, so we do have to change it sometimes. Make sure we pay very close attention to our labels, and we're good to go. So let's head back to the classroom, guys.